Today we're going to talk about graphing cosine functions. So we're going to start with just graphing the parent function, y equals cosine of x. And so just make sure that you note this is your parent function. So you're going to do all of your transformations from this function. Okay, so your parent function for cosine of x is actually coming from your unit circle. So if you were to evaluate cosine on your unit circle at 0, you would be up at the value of 1 right here. Now if you evaluate the cosine function at pi over 2, you're at 0 for your x value. And then when you evaluate at pi on your unit circle, you're at -1. When you evaluate at 3 pi over 2 on your unit circle, you're at 0. And when you evaluate at 2 pi on your unit circle, you're at 1. And so now you just connect this with a smooth graph and arrows on each end. And so that's your parent function for your cosine function. So if we go down, now we're going to look at y equals negative cosine of x. And so this negative sign in the front here, it actually reflects your function over the x-axis. And so we're going to take all of our values from our parent function. So if we evaluate our parent function at 0, we were at 1, but now we're reflecting over. Here, I'll graph the parent function quickly first for you. So the parent function will be in blue. And then I'll graph the transformed function in red. So we're going to reflect all of these points over the x-axis. And then we connect with a smooth curve. Get rid of those arrows on the end so it's not confusing. Alright, so now we're going to go to our next cosine function. And so this function is going to be y equals cosine of x plus 1. And this plus 1 on the end actually moves your function up 1, which creates what we want to call a midline. At y equals 1. And so your midline, if you look up here, the midline of these functions is actually just your x-axis at 0. And so same here, it's just where the middle of your function is. And so if we graph our parent function really quick, just so we can use it to transform everything. And we're going to move all of our points now up 1. And so if you look at this now, your midline is up here at y equals 1. And now we have y equals cosine of x plus pi over 2. And this plus pi over 2, so whenever you're inside the parentheses, you always remember it as the opposite. So this plus pi over 2 is actually going to move us left pi over 2, and this is what we call a phase shift. So I'm going to start by drawing our parent function again. And we're just going to move all of these points left pi over 2. Just like that. Now if we go to the next one, we're going to use the function y equals cosine of 2x plus pi. And so the first thing we always want to do when we have a number in front of our x value is we actually want to factor out that that number in front of our x value. So we're actually going to end up with y equals cosine of 2 times x plus, then you're going to take the value there, pi, and you're going to divide it by what you factored out. And so that tells us now this 2 right here is going to give us a horizontal compression of 2. And that tells you that your b value equals 2, and that's important, and I'll tell you why in just a moment. And then the next piece, right here, this plus pi over 2, is going to move us left pi over 2. Alright, so now if we go back to that b value there, our b value is important because we have our period, and to find your period, this is important, make sure you know this, your period is equal to 2 pi divided by the absolute value of your b value. And so in this case, it's going to be 2 pi divided by the absolute value of 2, which is pi. So our period here is only pi. So I'm going to first start with moving to the left pi over 2, and I'm going to create myself little asymptotes, like dashed asymptotes, just because it helps me with my graph. So I'm moving left pi over 2, so that means that I'm going to start my graph right here. And now I'm only going a distance of pi with my graph now. So negative pi over 2 plus pi this way gives us positive pi over 2. And so now, if you notice up here, we are broken all of our graphs. If I draw lines right there, breaks it into 1, 2, 3, 4 sections or fourths. So I'm going to break this into fourths. And so that's just going to tell me where all of my points are going to go in my graph. And so from here, I'm going to start by drawing my parent function in blue. And so we're moving all of our points left 2. So if we start with this first point on the left, it's going left 2. And then we know we're starting there. But then this next point here, it goes, if you look at the pattern, it's like starts up, and then it goes down, and then down again, then back to the middle, then back up. So we're just going to follow that pattern. So from here, we're going to go to our next dashed line, and we're going to go down to the middle. And then we're going to go next dashed line and down to the bottom, next dashed line back to the middle, and then next dashed line up to the top, and then we can connect our graph, and that's what it looks like. And then the next graph is going to be y equals 2 cosine of x. And so this 2 right here is going to give us a vertical stretch of 2, which actually tells us that our amplitude, so your amplitude, that's not how you spell amplitude, amplitude is equal to the absolute value of your a value, and this 2 is our a value. So in our case, it's the absolute value of 2, or just 2. And so that just tells you from the midline you're going to be going up 2 to your maximum point, or down 2 to your minimum point. So if I start with just our parent function, that means our maximum points are now actually going to be up at 2 instead of at 1. Our midline points do not get affected by this, and our minimum point is going to be at negative 2 instead of negative 1. So now we can connect this like so, and we have our graph. I have one more challenging one for you. So if we have y equals negative 2 cosine of 2x plus pi minus 1. We're kind of putting everything together now. So the first thing we need to do is factor out this b value in front here. So y equals -2 cosine 2 times x plus, remember we take this value, divide by what you factored out, and then minus 1. And so to graph this, I'm going to create some of my dashed lines again. So we know from this plus pi over 2 right here that we're shifting left pi over 2. So that means we're going to start our graph right here at negative pi over 2. This 2 right here is our b value, so remember your period equals 2 pi divided by the absolute value of that b value, so that gives us pi. And so we're only going this way an amount of pi. So negative pi over 2 plus pi gives us positive pi over 2, so our graph is going to end at pi over 2. And then remember, we want to break this into fourths, so I'm going to break this into fourths. And then so also here, this minus 1 is shifting our midline down 1. So our midline is going to be right here at -1 now instead of on the x-axis. And then we also know, according to this -2 in the front here, the amplitude of our graph is equal to the absolute value of that -2, so it's 2. So our maximum value is going to be 2 up from our midline, which is at +1 right here. And our minimum value is going to be 2 down from that midline, which is going to be down here at -3. So now, if we want to follow the pattern of cosine, which is, if it's a positive cosine, it's up, middle, down, middle, up. But the negative in the front here tells us we're reflecting it over. So instead of starting up, we're actually going to start down. So I'm going to graph this starting at the minimum value all the way to the left dashed line. And then we go to the middle on the next dashed line, and then we go to the top on the next dashed line, back to the middle, and then back to the bottom. And so then we connect this with a curve.